I'm going to be giving an overview of multiple MCC configurations in MPLAB Extensions for VS Code. So I previously made a video on this for the MCC Melody Content Library. Now I'm going to be showing some small differences with the MPLAB Harmony Content Library, but everything here is self-contained if you are using MPLAB Harmony. Okay, so why would you do this? Well, we have two similar boards here, one representing an evaluation board, and this is the PIC32CM MC, and this one representing your own board. Once you start to design it, you've added a feature, you've added a touch button, and maybe some other things. But this is the PIC32CM JH. So very similar microcontrollers. And we're going to show you how we can set up two MCC configs with slightly different pinouts, and how to handle the multiple MCC project configurations which need to be associated to each MCC configuration. Okay, so let's have a look and get into this. So first of all, we'll launch MCC, and note that we don't have an MPLAB project open, so we're creating MCC new config standalone because we have no MPLAB project configuration. We're going to call this one my MCC config, and it's going to be PIC32CM MC. And if we look at our connected boards, opening the MC, we can find our part number here, custom location, sometimes the standalone MCC just needs to be restarted. So there's the config that I created. And we can start to see the project files being created. Here we can see the actual config of MCC, and there's no associated project at the moment. Okay, so I'm going to use a very simple project config. In our system in Harmony here, well, it's related to actually system features in the Cortex-M0 Plus. There's a system tick. Cortex-M CPU includes an optional system timer, and we're going to use this system timer. So under system, Cortex-M0 Plus, systick enable interrupt, and we're going to just make it a 100 millisecond timer. What we're going to do, toggle a LED and debug IO. So I'm just going to the pinouts for all C nanos, and from here scrolling to the CM MC. Here I have the key output, the SIRCOM, connected to the embedded debugger, so that's for our, if we want to send hello world or use a terminal, that's what we'll use. Otherwise our LED is on PA23, and our debug IO, same pin as the switch, and PA22. So under ports, PA23, GPIO, LED, output, PA22, debug IO, also an output. Okay, so that should be our pin configuration. This is our project configuration, and at this point we can, if we want, generate code, and we will get a source folder, and in the MCC folder we have, well, here we have the components. So we have SimSys, we have core, So the sysdig period we can see already there. Okay, anyway, we now have main.c, so we can go back to our code. We can put this sysdig event handler, system initialize, then so after the system initialize, just paste the registration of the event handler, which we've just added, and starting the timer. Now we also wanted to toggle a debug IO. Okay, so that should be our code. Now you'd kind of want to compile this, but you can't because there's no project which holds all those kind of settings. So next step is to MPLAB create new project, and we're going to call this project PIC32CM, generally because we're going to use both the MC and the JH variants. So we're going to choose a custom location at the same level as our first MCC configuration. So here it's giving me the MC part, which we've just used, and we can use the XC32 compiler. So now in the VS Code we have a part number, our default.elf, the default configuration associated with a file set, and yeah, so all these major items, default. Okay, so let's maybe rename the default to be PIC32CM MC. We have renamed that, and now what we're going to do is associate the MCC configuration. Control-Shift-P, MPLAB, MCC, configure associated project. Now, I didn't need to open this file, but I'm just opening it so that you can see as we make the connection. So we add this configuration to this project and to the default configuration. There's only one config. So there we go. And we can see our config is now PIC32CM MC. There's our connection made, and now I'm going to put MCC on this side again, and now that these are connected, I'm going to generate code. Okay, you can see that this is quite a big file now, so we can see our config PIC32CM MC. These are the extra compiler directories, and here we have our file set. I actually want to just make sure that our file set is named file set, and that our toolchain is named toolchain. Okay, and notice the DFP here, because this is for the MC, so that is going to need to be updated soon. So let us run the project. So just clean and build it successfully, and let's launch. So we're going to create a launch.json at the project level, and here it picks up our project and our configuration. So now if we launch, we can choose our correct nano. Okay, I'm going to just open the data visualizer first. Not the JH, I'm going to use the MC, debug IO, and give it some space, start the project running, starts working, and Okay, so near enough 100 milliseconds, and the project is working as expected. So let's look now at the second phase, getting this working on a second board.